Pleasure to be here. It's like everyone else has mentioned, it's nice to be in an in-person event and actually see human faces in 3D. And thanks to the organizers for inviting me. Today, probably what I'm going to do is talk a little bit about not a specific project, but the problem we're trying to solve. Is it just me or is everything frozen? Okay, it's good. The core problem we're trying to solve, how we think about it at scale robotics, what are the practical challenges of taking technology into the industry and applying it in the real world? And then where the focus can be slightly different than actually this industry. So as a lot of people might have pointed out, construction is one of the world's largest industries, but it also happens to be one of the world's most wasteful and inefficient. So this is, I think, the key metric we need to take away. Like really 30% of a construction project ends up in a landfill. And I'm not sure if most of you are familiar that an average construction project operates in a 0 to 2% margin. So they're mostly at a loss. They barely make any revenue. But how does this compare to any other supposed manufacturing industry, right? Because construction is a form of manufacturing at the end of the day. It's on-site manufacturing. Traditional manufacturing or shop manufacturing has margins greater than 50%. And construction is abysmal. So why did this bridge happen? Is the big question. And our insight or our philosophy at Scaled is that construction lacks process control. Traditional manufacturing managed to implement process control. Basically, there's a reference input. You measure what's going on in your system and you figure out how these two things are diverged. And then you correct according to it. Construction does not have that. There is no simple and easy way to compare. So then how do you go about doing process control? And that's kind of the core of how we think about the problem. You can think about your reference input is as the BIM in construction. So I'm hoping that a majority of you know what a BIM is. And if you don't know, it's the building information model. It's the evolution of a 3D model over time. Basically, it's the construction process. This is what we want to build now, tomorrow, day after, and so on and so forth. We think of that as the reference input. The controllers are basically the people on the construction site. They're doing all the work, people, machinery, whatever. The physical system at the construction site. And then the way we do process control, we think about the problem is measure, because there's a lot happening on the construction site. There's people, logistics, material, etc. The question is, if to do process control, what do you measure? And an analogy I like to give, which is probably fairly useful, is the objective of construction is to recreate something in 3D space. So just measure the 3D geometry. This is probably the best proxy to do process control in construction. The same way, let's say if you're cooking, there's lots of things you can do to make your dish be exactly as the recipe dictated. You can also just taste it, because the objective of cooking is to something to taste the way it is. So think about it that as an analogy. But it's easier said than done to do process control in construction. Because first, your reference is always evolving. There's no fixed reference signal. A BIM is a living document. It keeps moving. And so is a construction site. There's not like one plan and they just go ahead and execute it. That changes on the fly. The second thing is it's an extremely nonlinear environment. We have an internal joke that the only thing linear about construction is gravitational causality. You can't build floor before floor 2, but everything else, there is no relation between what's happening in the different floors. Then it's a fairly non-trivial environment. Workers, materials, scaffolding, dynamic objects, occlusions. And here's the kick. It's extremely decentralized. If you've been on a construction site, you walk into any construction site and pull 10 different subcontractors and ask them what is happening, everybody will have a different answer. So it's a very complex problem of decentralized control. So how do you go about this? And yes, to add to all of this, it's also an open system. The construction site is not contained. So there is noise, occlusions, environmental factors that play. It rains outside, it's raining inside your construction site, and also probably at some parts it's not. Lighting conditions are really bad. Environmental effects are really adverse. So all of this actually creates opportunities to deploy solutions for you. And that's kind of a little bit what I'll be talking about today and what the practical challenges are. So there are two particular places where this is, at least for the process control problem. One is, how do you capture the data? And the second thing is, what do you do with that data? And I think this is a nice place to split how industry versus academia thinks. I think academia in this particular space is very focused on how to capture the data. And capturing the data, as someone in the industry right now, I'm not sure the value proposition is clear. So what the industry cares about is what are you doing with this data? So there are a lot of autonomy solutions, and I'm not picking on anyone specific here. I put our robot in there too. It's great. Maybe mildly gimmicky, but doesn't solve the problem because the industry really cares about why are you capturing the data and what are you doing with this data. In fact, to quote, I guess it was a long time back when I was a graduate student, Wolfram at ICRA said, if deploying a robotic solution, it either has to be better than humans, cheaper than humans, or both. It can't be neither. And I think a lot of solutions we're throwing out there end up in the kind of neither category. So why is this? Why do you see that particular solutions don't translate well? It's because the notion of sanitized environment, a couple of speakers spoke about it today. The way we treat construction. Here, it looks like it's a traverse. You can't move anywhere on that. There is no system that can. For everyone, let me fly a drone inside. That's not legal. You can't fly a drone inside. You can fly it around the construction site, but not inside. And there's a whole thing about focusing on complete automation rather than trying to take into consideration what the day-to-day operational setup is so that you can have impact on the construction site. Yeah. Then there's this, I think Michael went over it, a lot of object recognition, which is practically not relevant to 90% of the things that happen in construction. No one's tried to detect tabs, books, the detection challenges are not in detecting an object, but probably detecting the state of the object, useful or not. And that is where the value is. And everything that you're seeing, you're probably thinking in your head, that's a complex construction site. How do I get it to work? I would call this. I would call this a good day. Where we really work. This is just probably the only video I'll post. The work we do at Scale Robotics is working on construction sites. Like if you can turn off the lights, it's probably useful. Here, it's impossible to say what is building. It's not building. But we over a period of time have developed a complex set of algorithms that can go in. That can go in, automatically extract out all the low frequency, high frequency noise that deters the site or is there found in a typical construction site. Can filter that out. There's zero human intervention in any of these things. And then do some machine learning on it to tell you what the current state of the construction project is. But to give you guys a practical example, this is where there is value add in construction. When you want solutions to be deployed, they want it to be deployed in environments that are this complex. Sanitized floors, sanitized walkways is not generally where it actually works. So how can we actually have impact while taking solutions we've developed in academia to use on a construction site? I would say a couple of things is simplify the problem to add value, solve very focused problems. This whole probably leads into the debate we'll have later, which is any insight is better than no insight. So you really don't have to push for full automation. They just want things working so that they can save costs. And then there's another huge problem, which is simplify or make the problem robust. It's not about, as I guess Michael alluded to earlier, it's not about what is the best performance. It's like the thing has to work reliably. And how does that translate to real world problems? I hate to break it, but SLAM is nowhere close to industry requirements. I've heard this in so many workshops, like SLAM is a solved problem or whatnot. No, it's not even close. Make it simpler, add markers. They are trying to find something that is useful. So simplify your problem and try to deliver value. For example, our SLAM systems run offline because it is heavily optimized offline with a whole bunch of tricks because no one cares whether the thing can real time probably a little bit of navigation, but real time they're like, no. Also comes down to define your SLAM problem properly. Are you trying to navigate or are you trying to map? Two independent problems. Mapping to reconstruct has to be hyper accurate. Navigate, you just don't want to bump into things. So we've kind of focused on that. And this is kind of an example of some of the work we've done on SAM. I'm going to detail this. What I just want you to take a look at is work in an environment where everything is shiny. So there's literally no LiDAR, what do you call it, returns coming back. But this too is a very simplified, sanitized environment. The actual system, like I showed, was in the crazy little mess earlier, which is where we had to work. The other thing about solving focus problems, use domain context. Domain context is very, very important, and general purpose object detectors are not things people care about. For instance, there's this whole thing, object detection, this, and that's really what not the industry goes about. If you start going in and looking for texture and trying to use it, well, congrats. On the construction side, everything is great. You're not going to be able to detect anything with your object detectors. They care about more specific things. Is there a reservation at point X, or is my pipe off by so much? Because those are the value adds. And as you can see, probably on the site, to solve those problems, to give them very precise pose information, we actually have markers on the site. And no one is opposed to putting markers on the site as long as you solve their problem. So this goes to my final bit, which is any insight is better than no insight. And this nicely bleeds into the debate we'll have later. I see as robotics and AI in this sector as a means to enhance work and decision making, but not to replace. If you think you're replacing labor, you're trivializing the complexity of what is happening on a construction site. Maybe the big misconception is there is a shortage of labor. No, there's no shortage of labor. There's a shortage of skilled labor. And skilled labor is hard. So you want to try to reduce the complexity of the task through robotic automation so that it can be done much more efficiently, much more quickly. At least that's my personal take. And we have actually deployed our solutions on construction sites. This is just one, but just to give you a kind of an idea, this is not even from our press photograph. This is from one of our clients who was actually deploying or did a press thing. And the point was, they were like, guys, we need it to work. So if you need a person to drive around, it's fine. It has to work. That's the ultimate objective. And this also goes into how you think about problem solving. I learned this talking to someone at Google Search, and that person had a very, very, one of the first people involved in the project, had a very useful insight about how you think about robotics and automation. If you think about the Google search bar, it's not giving you the right answer. It's giving you the most relevant answer to your query. So basically, it is automating the task of looking for solutions or reducing your search space. So we should probably start thinking about when we deploy robotic solutions in the industry, especially in the construction industry. It's a complex environment with a massive search space, a lot of noise. And in all of this, if you're going to attempt full autonomy or some kind of outrageous accuracy, you're probably going to fall flat because you're trivializing the complexity of the environment. It's better to just try to focus or to have real world impact, like impact tomorrow, impact within the next few years, rather than what is going to happen 50 years. Is to try to just enhance decision making. If there is a robotic platform that needs to do X, maybe what is required is to reduce operator load and make sure the interventions are really low, rather than this thing has to run all the time, but it's not reliable. That probably is where I will wrap up. What we do is this kind of principle we apply to our quality control. Like you saw, we do process control on construction, but if I just go and dump that on a construction, site manager or BIM VDC manager, they'll still gawk at me. It'll be like, okay, you do realize a building, a classic building, probably has close to 1 million BIM elements. No one over here, if you give them a raw signal saying, hey, by the way, I filtered it, these are all the things that are wrong, he'll be like, great, Einstein, I knew they were wrong. Because 99.9% of the buildings that are built are never according to plan. What they probably care about is what is really damaging to my project. And that's where you start creating efficiency and cutting down margins. So that mentality we've taken into our problem solving is this complex machinery of structure for motion, machine learning, 3D recognition, all this happening. But most useful thing for the client It's about giving them that solution in a quickly accessible way. And working backwards, the industry wants is much more useful than here's a tool to, push it as possible. So thank you to an awesome team. I want to spend a minute talking about value diversity a lot. And one of our key mottos and philosophies is diversity in people, is diversity in thought. So maybe that also applies to robotics, is applying it to construction. Don't think of it as a roboticist. Bring in the civil engineer, bring in the architect, bring in the site manager, bring in everyone who's on the construction site before you start designing your solutions, because that is ultimately what will have impact than strictly thinking about it as a object detector plan or whatnot. And that's my time.